Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mariam Akhtar and I'm from the Department of BS Chemistry. My ID is 004 and this is the course of Organic Chemistry. And the topic of this presentation is of alkenes. The table of contents are as follows. First of all, we'll see the 3D model of the ethylene, then structural isomerism in in alkene, and then structure and geometry of alkene, and after that shape, physical properties, chemical properties, and in chemical properties is all the reaction included, and after that we'll talk about the nomenclature, and then cis trans isomerism, and after that EZ notation, and after that what is the difference between E and Z notation, its application in which it includes industrial importance of alkene, uses of alkene in medicine and its application in plastic synthesis, in which ethylene is used as the industrial feedstock and propylene is used as industrial importance. After that, we'll move toward the Hawk process and removal of oil spill. And then we'll talk about the preparation and reaction of the alkene. So, what is alkane? Alkane are basically the unsaturated hydrocarbon which contain carbon-carbon double bond, and it is depend upon how many double bonds are present in a molecule, which through which we can indicate it alkane diene, alkane triene, alkane tetraene, and so on. It is also of alicyclic and aromatic compounds. In aromatic, we can see cyclic structure, and in alicyclic, we can see the branch or simple straight line function. Structural isomerism. Those isomers which are structurally related with each other but have similar molecular formula are known as structural formula. And its structure for isomerism, it starts from the carbon 4. Butane has 3 isomers, carbon 5 has 5 isomers, and so on. Isomers continues and it goes to million and trillion. The structure of alkyne, alkene can be seen through this ethylene, showing this is the pi bond and delocalization of the pi electrons. And this is the carbon atom, and these two are the hydrogen atom. And these are the structure of the ethylene. Basically, what happens here, there is overlapping of the atomic orbital, and which is between the carbon-carbon double bond. One is sigma bond, and the other one is pi bond. In hybridization, we see it is sp2 hybridized, which in which S and p orbitals hybridized and form three sp2 hybridized orbital, and along with the unhybridized 2p orbital will get delocalization and get pi bond in the alkenes. The shape is predicted through the Vesper model of the electron pair repulsion theory, and it can vary because of the steric strain. The example are of carbon-carbon double bond and the angle is 123.9. In physical property, we can see that it is as similar with the alkanes because they are colorless, they are non-polar, they are combustible. And in physical state depend upon the molecular mass because for just like unsaturated hydrocarbon, the simplest alkane, ethene, propene, and butene are gases at room temperature, while from 5 to 16 carbon atoms, the alkenes are liquid in nature. And from higher alkene, we can see a waxy solid. Melting point and boiling point increase in the molecular mass. And now we are moving towards the chemical properties. And these chemical properties are as follows. These two addition reaction and these addition reaction are as follows. Hydrohalogenation, halogenation, halohydrin, hydroboration, dichlorobraine addition, Siemens-Smith reaction, catalytic hydrogenation, radical polymerization, hydroxylation, etc. Now, what is hydrogenation? Hydrogenation is the introduction of the hydrogen atom into the alkenes. The condition is the temperature should be 200 degrees Celsius and the catalyst must be platinum, nickel, or platinum. Red and nickel is basically used for the hydrogenation of alkenes. This is the alkene. When it is hydrogenated, we get our desired product alkane. In hydration, the addition of water across the double bond of the alkane which yields alcohol. Hydration of alkene produce alcohols, in which we use the catalyst phosphoric acid or sulfuric acid in industrial importance. This reaction is carried out on industrial scale to produce synthetic ethanol. And this is the reaction hydration of alkene gives alcohol. Halogenation is a process in which halogen atom is imparted into the alkenes. This is the analytical test, and this is the reaction in which halogen atom is introduced into the alkene and we get vicinal dihalide. This reaction is of great importance. Halogenation. Hydrohalogenation is the process in which there is addition of the hydrogen halide HCl, to alkene to yield the corresponding haloalkane. And this basically done through a rule which is known as Markovnikov rule. If the carbon atom at the double bond are linked to a different atom of a hydrogen bond, the halogen is found preferentially at that carbon which has hydrogen in lesser number. And this is called Markovnikov rule. Halohydrin formation, in which halo means halogen atom and hydrogen means water molecule. This is reacted with the alkene and we get alcohol. Oxidation is the process in which with the help of oxidizing agent we oxidize the alkenes. Ozonolysis in which we impart the ozone into the reaction and yields aldehyde or ketones. Conditions for this are the cold or hot KMnO4 and the reaction is this. Polymerization is the process in which different monomers are combined together to form a polymer. For example, polyethylene and polypropylene. These are plastic. Metal complexation. Alkenes are ligand in transition metals such as alkene complexes. Mono and diolefins are often used as ligand in stable complexes. In synthesis, we can see the industrial method in which raw material are primarily ethene and propane. And the condition should be high temperature and zeolite catalyst, primarily aliphatic alkenes. It is the mixture in the feedstock and temperature dependent and separate the fractional distillation. Now I'm going to talk about the elimination reaction in which for the alkene synthesis, the principal method is elimination of alkyl halide, alcohol, and similar compounds like these. This is done through the beta elimination, which is of two types, E1 mechanism or E2 mechanism. But alpha elimination are also known, but it is very rare in alkenes. Now moving towards the application of the alkenes. Alkenes are of great importance as it is used in alcohol, plastic, liquors, detergent, and fuel. And the uses of alkene in medicines are in pharmaceutical preparation, in plastic and rubbers, etc. The industrial importance of the alkene are as follows. As we know that it is very useful in the production of the polymers, for example, plastic and polyethylene and polypropylene. Polymers with the monomers are as follows. Ethylene, this is ethylene and this is its structure and this is its example. And this is the plastic bog. These all are the monomers through which we can prepare our polymer with an example or usage. It is of great importance in the plastic, in movies, in videotapes, in cassettes, in recording tapes, in overhead transparencies, compact discs, and discs. It is used as a starting material in the industries. Now moving towards the geometry. Its geometry is sp2 hybridized. So what is the preparation of the alkene? Alkene can be prepared through 7 rules or 7 methods. Dehydrohalogenation, dehydration, Dehalogenation of acetyl halide, electrolysis of the salt, and pyrolysis and Witts reaction. So first is the Witts reaction, in which we can see that this is a triphosphine which reacts and give methylene triphenylphosphorine iodide. And then we'll get our desired product alkene. The second one is from alcohol. As we know that there are different types of alcohol, primary alcohol, secondary alcohol, and tertiary alcohol. All the condition will differ in every single condition. For primary, we see that there is 75% and the temperature also differ in the both in the among three primary, secondary, or tertiary alcohol, and we get our respective alkenes from these all. From alkyne, we can see from alkyne we can also produce our respective alkane, but there's a difference of the location of the carbon atom. Since alkane and transalkane by differencing of the conditions. The next separating method is of cold electrolytic method, which is from the electrolysis of the salt of dicarbonic acid, which is succinic acid. General reaction is of dicarbonic acid of sodium, which are done through the electrolysis and which get two cations. At anode and cathode, there are two different reactions, and the next one is dehydrohalogenation of alkyl halide, in which we react the alkyl halide with alcoholic KOH and we get a respective alkene. The eliminating order of our tertiary, secondary, and primary. Now I'm talking about the reactions of the alkenes. The reaction of the alkenes are as follows. The first one is of addition reaction, the second one is oxidation reaction, and the third one is polymerization. So, polymerization is a process in which monomers react with each other and form polymers. These are the example of the polymerization. Ethene form polyethylene, which is of good quality and obtained in the presence of these titanium tetrachloride. In addition reaction, we can see that we can add the sulfuric acid, we can also add the halogen, and we can done it through the Markovnikov rule, and these are the desired product of these. When the alkenes react with the following, these are halohydrin formation, Markovnikov rule that we have discussed very earlier, oxidation of the oxidation reaction in which oxygen react with the alkene and we get two sole products, carbon dioxide and water. But in the case of addition of oxygen, we can also get this polypropylene oxide, means epoxide can also be produced. In hydroxylation, in which hot cheminophore is added and we get our glycol, means diol, we get it. Ozonolysis, in which there's a rearrangement and we get ozonide. These are the summary of this reaction. It can easily be seen that this is alkene. It can also form vicinal diol. This can also form epoxide, halohydrin, vicinal dihalide, alkyl halide, ketones, aldehyde, carboxylic acid, ether, and alcohol. And that's all from my side.